Hello, this is the third video in changing the subject of a formula or rearranging formulas. Okay, now if you look at this first formula that we have here on the left, we've got the operation square root of m. So that actually turns out to be an example of an index. So what we have to do is do the opposite operation of taking the square root. And the opposite of taking the square root is squaring. So I'll write squared, and I square both sides. Squaring and taking the square root cancel each other out. For example, 4 squared is 16. Square root of 16 gets you back to 4. So squaring and square root are inverse operations. So once I've canceled out those, that leaves just an m, which I'll write on the left-hand side. And on the other side, I've got a p squared, which I'll write on the right-hand side. Yeah, let's have a look at the equation underneath it. I'll just move it up a bit higher, so I've got plenty of space to do the work. Okay, now you also need to sort of think of the square root as being like brackets. So I can't do anything inside the square root until I get rid of it. So you might think maybe I should multiply both sides by 2 because of the divide by 2, but we actually have to get rid of the square root first. So once again, I'm going to start by squaring both sides. And the reason is the square root and the squaring cancel out. That leaves just m over 2 on the right-hand side and p squared on the left-hand side. Now I can say m is divided by 2, and therefore I need to multiply both sides by 2 and multiply that side by 2. The 2's cancel out, and that leaves me just an m on this side, which I'll write on the left, and a 2p squared, which I'll write on the right. Okay, what if we have an m squared term? Well, again, that's indices. So add and subtract first. Well, we don't have any adding and subtracting. Multiply and divide second. We have 5 multiplied by m squared. So we need to first undo multiplying by 5, which is dividing both sides by 5. Again, the 5's will divide out, and that leaves an m squared on the right and a p over 5 on the left. I'll just move this other equation down for the time being. Okay, the final step is we have to get rid of the squaring. And again, the inverse operation of squaring is taking the square root. So I take the square root of m squared. I take the square root of p over 5. The squaring and the square root will cancel out. And all I'm left with then is just the m, which I'll write on the left, and what it equals, which is the square root of p over 5 on the right. Okay, let's go ahead and do the last one of these 4. So I've got p equals, in brackets, m plus n all squared divide 2. So once again, brackets is the last thing we do. So we don't touch anything inside the brackets until we get rid of all the other factors and terms. So in this case, I have to get rid of the divide by 2, excuse me, by multiplying by 2. I'll use my dot for multiplying. And here I can just write the 2 in front of the p. And 2 divides out the 2. That leaves me with m plus n all squared. And on this side, 2p. Okay, now once again, I can't do anything inside the brackets until I get rid of the brackets So now I have to undo the squaring, which is to take the square root and take the square root. Squaring and square root cancel, or their inverse operations, and that means on the right hand side I end up with m plus n. On the left hand side, just the square root of 2p. That can't be simplified in any way. And finally, the last operation, the expression that was originally inside the brackets, I can subtract the n from that side. I can subtract the n from that side. The plus n minus n cancel out, and that leaves just an m on the left, sorry, on the right. And I'll write it on the left, and square root of 2p, square root of all of 2p, subtract n on the right. And that's basically how we work with equations involving squares and square roots.